Hello everyone, I am Brandon Ordonez from ECE 31 and today I'm gonna perform our experiment number 5 for our Digital Electronics 2 laboratory. The objectives of this experiment are to build a circuit which applies 8-bit analog input, to simulate and program a code that would use an analog to digital converter peripheral, to present the results using an LED as an output. So now let us begin with the experiment. First, open MPLAB XIDE, then create new project. So after creating a new project, click MCC and click Save. First, we would go to device resources, peripherals, ADCC, and double click. There. After adding ADCC, go to System Module, Oscillator Select, Page Pin TOSC, High Frequency Internal Clock 4 MHz, Clock Divider 4, and Low Voltage Programming enabled. Next, first, choose port A0 as the input, double click until it turns green for the ADCC, and for our pin module, click port A4 as our output. There. So again, port A0 for the ADCC input and port A4 for our pin module output. Next, rename. So for the pin module output, we would rename it D2 underscore LED. Then for the ADCC input, pot underscore A0. There. So uncheck the analog for the RA4 pin and check the analog box for the RA0 pin. Next, we would check output for our RA4 pin, since this is where the LED would be connected. We leave the output box unchecked for the RA0 since this is our input. Next, go to ADCC under Project Resources. For the clock source, it should be FOSC ADCLA. There. For our clock, it should be FOSC/2. There. So for the result alignment, it should be right, positive reference VDD, negative reference VSS. After that, click Generate. So after generation is complete, go to Projects, Experiment 5, Source Files, Main C. Go to our main function under the while loop. Under the while loop, type ADCC underscore initialize. There. Next, if underscore ADCC underscore get single conversion, then our input name less than 512. For our if condition, we use ADCC underscore get single conversion because if we would go to our header files, MCC generated file, and our ADCC.h, we would see that the variable that the command used is ADCC underscore get single conversion, while as shown from our PDF, it is ADCC underscore get conversion. I have tried this code, but it wouldn't build. So instead, we would use ADCC underscore get single conversion because it is the one written in our ADCC.h file. Next, after that, set your condition D2 underscore LED underscore set high. Next, for else D2 underscore LED underscore set low. There. So this would be our main code. First, we initialize the ADCC so that it calls the function to be used, or the peripheral to be used. Sorry. Then this code is used so that the macro is used to select desired channel for conversion. So this would be our condition such that if the value of the input is less than 512, our output would be the LED would light up. Otherwise, the LED would not light up. Then go to build. There. After build is successful, go to MPLAB XIPE and connect your microcontroller. So now we would be connecting our microcontroller to our personal computer using our kit. There. Now it is read by the system. So now that we have connected our microcontroller to our circuit, click connect. Since I have already used our MPLAB XIDE earlier, I have already set the voltage level to 3.125 and our power target circuit from 2 to 3 is checked. This is accessible through settings and advanced mode. The password is microchip. Now, after connecting our microcontroller to our personal computer, we would load our hex file from your destination folder, experiment 5, disk, default, production, and there. So after hex file is loaded successfully, click program. After programming is complete, disconnect. Now, we would connect our microcontroller to our circuit. So now that we are done connecting our microcontroller to our computer and programming our code, we would now attach it to our breadboard. So first, attach your microcontroller. I have already prepared an LED and a resistor which is connected to the ground. There. Since we would use an LED as our output. First, let us connect our output LED, which is at pin 6, to our LED, which is then connected to our resistor, which is connected to the ground. Next, get your potentiometer. There. This is a 10 kilo ohm potentiometer. Connect it to your circuit. So, here, the leftmost pin should be connected. To our positive terminal. Next, the second pin should be connected to pin 2, which is RA0. Next, the third pin, the rightmost pin, should be connected to the ground. There. So now that we are done connecting our inputs and our outputs, we should now connect our VDDs and our VSS. There. Now that we are done connecting our circuit, we should get our power supply, which is a 5-volt power supply. There. And connect the positive terminal there and the negative terminal to our circuit. There. Now let us connect our 5-volt terminal to our outlet. Initially, our potentiometer is turned to the left, there. So the LED does not light up. Therefore, with reference to our code, the value that is given by our input is greater than 512. Therefore, the output is off. So if we turn our potentiometer to the right, it lights up. Therefore, the input is less than 512. So again, if we would turn our potentiometer to the left, is here, to the left, output is 0, which means LED is off. Then if you turn it again to the right at maximum point, the result is 1, which leads to LED being turned on. Conclusion: the experiment used a PIC 16F18875 microcontroller in order to apply the 8-bit analog input into a schematic formed using a breadboard. The experiment was able to convert an analog signal into a digital signal using an ADCC peripheral within MPLAB XIDE, wherein a condition is set, with a certain value set as the middle point. If the input value is less than the middle point, the digital output would be 1. On the other hand, if the input analog value is higher than or equal to the middle point, the digital output would be 0. For a digital output of 1, the LED is expected to light up. Otherwise, the LED is expected to remain unlit. The experiment was done successfully as seen from the results section of the video, as it is seen that by using a varying resistance component or a potentiometer, the range of resistance varies with the output. If the potentiometer is set to be at its maximum point, a result is gained, while at its minimum point, the opposite of the initial result was observed.